Hello, this is Javon. This is my physics. So we have this physics problem, and it's a circuit, and we're trying to find the equivalent resistance. So we have these given values: 6 ohms, 4 ohms, 10 ohms, 7 ohms, and 15 volts. And we're trying to find the equivalent resistance. So for the first part, we have these two, 4 ohms, and we have 10 ohms. And we have both of them in series. So for series, we just add them up. So you get the 4 ohms plus the 10 ohms, you get 14 ohms. That's 4 ohms plus 10 ohms, 14 ohms due to series. So for this part, we have 14 ohms and we have 7 ohms. And for these two, they're in parallel. And in parallel, you have to use the reciprocal. So right here, the 14 ohms and the 7 ohms, the 1 over 14 due to reciprocal, 1 over 7, you add them together, you get 3 over 14. You flip it back, you get the reciprocal. So you get 14 over 3, which equals 4 2/3. And I got this from the 14 ohms and the 7 ohms. Right here. We have the 6 ohms, we have the 4 2/3 ohms. We add them together because they're in series. And in series, you just add them. So you have 6 ohms plus 4 2/3 ohms equals 10 2/3 ohms, which is the equivalent resistance. So backtrack. 4 ohms plus 10 ohms equals 14 ohms. You got the 14 ohms because it's in series. You have the 14 ohms and you have the 7 ohms, and you get the 4 2/3 ohms due to parallel. And you use the reciprocal, which you flip, which I got the 1 over 14 plus the 1 over 7 equals 3 over 14. Flip it, reciprocal, 14 over 3. Right here. You have 6 ohms plus 4 2/3 ohms equals 10 2/3 ohms. And I got that because they're due in series and they equal each other.
Hello, my name is Alana Williams, and I'm going to be showing you guys the second part of our physics problem. So we obtained from the first part that our equivalent resistance was 10 2/3 ohms over the entire circuit, and we have our given voltage, which was 15 volts. And we're going to take those two values and plug them into our Ohm's law equation, which is current equals voltage over resistance. So we have 15 volts over 10 2/3 ohms, which will give us a current of 1.41 amperes. So now we have the current of the whole circuit. So we're going to move back to when our circuit included the 6 ohm resistor and the 4 2/3 ohm resistor. Now we know that the current over each of these resistors is 1.41 amperes because they're connected in series. So now we're going to use a variation of Ohm's law to obtain the voltages over each of the resistors. So we take the current, which we have here, 1.41 amperes, and the resistance of the first resistor. So we multiply them, 1.41 amperes times 6 ohms gives us a voltage of 8.44 volts. And then for the second resistor, we do the same thing. We take the current, 1.41 amperes, and multiply it by 4 2/3 ohms, and that gives us a voltage of 6.56. So now we move back a step further to when we had the 14 ohm resistor and the 7 ohm resistor connected in parallel, and the 6 ohm resistor connected in series to that. So we're trying to find the voltage of this 7 ohm resistor, and basically we know that it's going to be 6.56, just like the 6.56 volts up here on 14, because these are connected in parallel and the voltages will be the same. So our final answer will be 6.56 volts.
Hi, I'm Chase Crowder, and I will be explaining how you find the current that goes in the 10 ohm resistor. First, we're going to go back to part 2. In part 2, she found the voltage, basically for all resistors. for a resistor, the 6 ohm resistor, the 7 ohm resistor, and the 14 ohm resistor. So finding that, she also found that the current that goes through the whole circuit is 1.41 amps. So with that, I'm trying to find the current that goes within the 4 and the 10 ohms. So initially we have the 1.41 amps. As you can see over here, will be with the 6 ohms. And with that current, we will find the 7 ohms, which we found to be 0.94 amps. So I'm trying to find the current that goes through the 10 ohms. To find that, I will then, for the 6 ohms, of course I have the 1.41 amps. So I'm going to take that and subtract it from the current of the 7 ohms, which is 0.94. And what will that equal? It will equal 0.47 amps. So finding that current that goes through the 4 ohms and the 10 ohms will be 0.47 amps. This shows that with these two, when you add these two up, it will initially come to 1.41. So my question is to find the current that goes through the 10 ohms, which will be the 0.47 amps because they are connected in series. Credits part 1 that Javon Anderson answered was the equivalent resistance. Part 2, Alana Williams, she solved the voltage of the whole circuit. And me. Part 3, Chase Crowder found out the current that goes through one resistor. And our video man, Robert Jackson.